and the two-sided limit, and then we learn about how to compute the limit by looking at a graph. Okay, then we observe that table is not a great tool when we discuss about a limit. You can find some idea but not exact value. Sometimes maybe not exact value. Okay, if we get this alternating function. Okay, thank you. Okay, so if we have this alternative function like this, limit is not defined. Okay, we discuss this situation and then we look at this definition. Okay, and then we learn how to apply that definition to graphs and decide whether it's continuous or not. Okay, then this is the formal definition for continuity. We will not discuss it in this class. Okay, if you take a more advanced class, you will use this definition. We use the intuitive version. Okay, so now we are going to algebraically compute limit. Okay, there we have this rule set. Okay, so this rule set, constant limit rule, says that for a constant function, limit is always constant. Okay, so for example, that constant. Okay, we take a function like this. Constant function means we have a function like this and all the values function is constant, no? At some fixed value. Like this at a k fixed value. Okay, so this value is, let's say, k. Sorry, k. Now if we take any point on x-axis, let's say c, as x approaches c, this value always remain k, no? So that means both limits are k, so the two-sided limit is also k. So we can say limit c k, no? Constant function here, this fx is k. Okay, is k. So if there is a constant function, limit is always constant. Then you have multiple rules. Okay, here we are supposed to find the limit of a function multiplied by a constant. So here in the left side, here first we multiply the function by the constant, then pull out the constant. But other side, sorry, then calculate the limit, no? So first we multiply the constant by a function by a constant and then calculating the limit of the resulting function. But other side says instead that I can pull out the constant and then calculate the limit of the function. Okay. So for example, if I want to find, okay, before that I'll go over the rule. So, okay, some rule says here I am supposed to find the limit of a sum. That means first I add the function and then calculate the limit. Instead of that, I can calculate the individual limit of each side and then calculate the sum. Sorry, excuse me. And so, okay, this one again, the definition for continuity. So we can prove that x is continuous on a real set of value using this epsilon delta definition. You don't have to know the limit. Okay, you can know that fx equals x is always continuous on a set of real numbers. Okay, so with that we can say that polynomial functions, rational functions, and trigonometric. So polynomials, rationals, and trigonometric. Polynomials and rationals to be continuous at a points where the function is defined. Okay. Additionally, we can say trigonometric functions and trigonometric equation, exponential and logarithm functions to be continuous at any point where function is defined. Okay. So this මේ theorem එකෙන් කියන්නේ අපිට polynomial function, rational functions function එක define වෙලා තියෙනවා නම් point එකකදී continuous කියලා ගන්න පුළුවන්. ඊට අමතරව trigonometric functions, trigonometric inverse functions, exponential functions උත් continuous කියලා. හරි, ඒක prove කරන්න පුළුවන්. අපි දැනට graph පාවිච්චි කරමු. හරි, මේ තියෙන trigonometric functions වල graph. Okay, these are the graphs of trigonometric functions. So you can say sin x and cos x is continuous in all the values. Okay, tan x is continuous except at these pi over 2 multiples. Okay, except at pi over 2 multiples, tan x is continuous. This pi over 2, negative pi over 2, and then 3 pi over 2. Okay, odd multiples of pi over 2, tan x is continuous. Same way secant x is continuous, cosecant x. Okay, in these intervals, and secant x and cot x. Okay, all of them are continuous except the points where this function goes undefined. Then here inverse function, tan, cos, tan inverse, cot inverse. So these are also continuous in the all domain, no? All domain where the function is defined. Okay, here it's defined between -1 and 2 only. Okay, so when you find the limit, then this is exponential and ln x plus. These are continuous functions in points where the functions are defined. Okay, so we observe that if function is continuous, we have this rule where instead of the limit x going to c, I can plug into the function. Okay, so together with these rules, we can find the limit of more complicated functions. අපිට මේකට අමතරව මේ complicated functions වල limit හොයන්න මේ ක්‍රමය පාවිච්චි කරන්න පුළුවන්. Okay, so we use these rules together with that continuity theorem to calculate the limits of complicated function. Okay, so for example, let's say I want to find the limits of following functions. Okay, here I write here. Let's say we are supposed to find the limit of this one. You can see the whiteboard. No, if you cannot see the whiteboard, let me know. Okay, so let's say I want to find the limit of this limit. What can I do? I can pull out this constant using the constant multiple rule. Okay, because I don't know whether 5x is continuous I know only cos x is continuous, so I cannot plugging in at this point. Okay, so I'll go limit x goes to 0, cos x. Okay, 5 is continuous, so I pulled it out. Okay, I have cos x. Okay, now this one is continuous from that list, no? So if it is in that list, we can plugging in. Okay, so the cos x is in that list, so I can plugging in. Here, first I use the constant multiple rule and pull out a constant. Okay, see this cos x is in the list, no? So we can use this second rule where we say, if I want to calculate the limit of a constant time function, first I can pull out the constant and then calculate the limit. Okay, so I use that rule here. I pull it out the constant. Okay, මේක දැන් මේ rules limits හොයනකොට මේ list එකේ තියෙන function එකක් වුණොත් ඒකට plug කරන්න පුළුවන් continuity theorem එක පාවිච්චි කරලා. continuity theorem 2 එක. එතකොට මේ list එකේ නැති function එකක් නම් ඒ rule එකක් දාලා ඒ list එකේ එක limit එකකට හරව ගන්න ඕන. Okay, දැන් මෙතන තියෙන මෙන්න මේ continuity theorem 2 එකෙන් කියන්නේ මේ functions ටික continuous කියලා. එතකොට ඒව මේ defined point වලදී. එතකොට ඒක continuous point එකක් නම් අපිට function එක plug කරන්න පුළුවන්. එතකොට මේ list එකේ නැති function එකක් ආවොත් අර rules දාලා මේ list එකේ තියෙන function වලට කඩා ගන්න ඕන. Okay, so if your function is in the list given by the continuity theorem 2, you can directly plug in to find the limit. Okay, so if that function is not in the list, you apply one of rules from here to make it to break it down to a limit of a function in the list. Okay, so here this 5 cos x is not in the list. I have only cos x. So what I did, I pull out the 5 and then using this rule, I pull out the 5. Then I have to calculate the limit of cos x. Okay, I have to calculate the limit of cos x. Okay, so for that one, I can apply, it's in the list, so I can plugging in directly. No, මෙතන මේ cos 5 cos x කියන එක නෑ list එකේ. හැබැයි අර constant multiple rule එකෙන් පහ එළියට ගත්තාම එන function එකට plug කරන්න පුළුවන්. එතකොට මෙතනට එනවා 5 cos 0. Okay. If you look at another one, let's say this one.
මොකක්ද අම්මා? ඔව් තව එකක් තියෙනවා.
Okay, mute the mic. Okay, thank you. Let's say here we have this function. Okay, exponential. So this function is not given in the list. Okay, but this is a polynomial function. It's in the list. Polynomial functions are in that list, and exponential function is in the list. Exponential function is this exp. Okay, let's say x going to 1. So first I break it down to 2 pieces. Limit x going to 1, this polynomial function, plus limit x going to 1, exponential function. Okay, so you break it down to two ones because this is a polynomial, no? So the polynomials are in the list, and this is an exponential function. It's in the list. This exp, this guy is same as expx. Okay, so that is also in the list. So now I can plug in because they are continuous functions. So I can plug in 2 times 1 in the list. Okay, and e to the 1. Okay, so 2 times 1 is 7, 2 times plus 5 is 7, and e to the 1. Okay. So what we do, if it's in this list, we can directly calculate the limit. Otherwise, we have to apply one of these rules. Okay. So this list contains polynomial and rational function. You already know, we discussed what is a polynomial. Rational is a division of two polynomials. Okay. Then we have trigonometric functions and inverse trigonometric exponential log. Okay. So this is exponential function. So you break it down using the sum rule, then you can use exponential function rule and plug it in. Okay. Okay. So here we again come here. Okay. So here again, this first guy is a polynomial function. Second guy is a logarithmic function. Okay. So product function is not in the list. Okay, I have this polynomial function in the list, logarithm function is the list, but this product is not in the list. මේ product එක list එකේ නැහැ. එතකොට ඒකට plug කරලා limit එක හොයන්න පුළුවන් නේ. ඒකට මුලින් දානවා product rule එක. Okay, I have to break it down until it's a one listed in that list. අර list එකේ list කරපු function එකක් වෙනකම් break down කරන්න ඕන. Okay. Here I break it down using the product rule. Okay. Here I use the product rule. This one. Okay. Product rule. I have a product of two functions. Then the output is I find here says first multiply the two functions and find the limit. Here it says first find the limit of individual functions and then multiply. Okay. So that is the product rule. Here I am applying that product rule because this is a polynomial function and this is a exponential, sorry, logarithmic function. So it's in the list. After this, I can plug in it. Okay. Oh, okay. Ln0 is going to be undefined. Okay, I'll use some other value because we didn't discuss the limits to infinity yet. It's not defined. So here, let's say 2 or something. Okay. Sorry, 2 because ln of 0 is not defined. I forgot that one idea. Okay, so this one. So now this is defined at 2. Okay. So you can go to here. I do 2 square plus 5 times 2 plus 6. Okay, times ln of 2. Here I can plugging into this. After that, individual limits. Okay. So this is for 10, 20, no? 20 times ln 2 is the final answer. Okay, unless I use a okay, do you have any questions up to now? මෙතෙන්ට එනකම් මොන හරි ප්‍රශ්නයක් තියෙනවද? Okay, E වල අගයන්නේ අර අනිත් එක තිබ්බ ln. Okay. E වල අගයන් හොයන්න මේක exp කියන්නේ තත්ත්වයට function එකක්. Okay. For example x or ex. Okay. ex මේක function එකක්. මේක e2 වගේ ආවතින් let's say e2 වගේ මේක e times e. Okay. එතකොට මේක calculator එකකින් හොයන්න පුළුවන්. calculator එකකින් හොයන්න පුළුවන් අර scientific calculator එකක් පාවිච්චි කරොත් e වල අගයන් හොයන්න පුළුවන්. එහෙම නැත්නම් එන්නේ ln. හරි ln ම තියෙනවා මෙතන. ඒකත් calculator එකක් පාවිච්චි කරන්න පුළුවන් මේ log අගයන් හොයන්න. උදාහරණයක් ඇටියට log base එක මෙහෙම වගේ වුණොත් පුළුවන්. log 100 වුණොත් දෙකයි නේ. මේ ln කියන්නේ e පාදය. මම ln කියලා දැම්මේ. හරි e පාදයේ log එක. එතකොට මේක දෙක වගේ වුණොත් calculator එක ගන්න නැතුව හොයන්න අමාරුයි. හරි ln කියලා දාන්න lnx කියන්නේ. එතකොට ln දෙක කියන්නේ ඒක එහෙම calculator එකකින් නැතුව හොයන්න අමාරුයි. මේ e වර්ගත් calculator එකකින් හොයන්න පුළුවන්. එහෙම නැත්නම් මේක තිබ්බනම් හරි. මේ e2 විදිහට calculator එකක් තියෙනවා නම් scientific ඒකට plug කරලා හොයන්න පුළුවන්. Okay, so this find values of e and ln. You if you have a scientific calculator you can plug in it. Okay. Or otherwise you can leave it like this. Okay, ඒක පැහැදිලිද දැන්? Is it clear now for the person who asked the question?
Yes, sir. Thank you.
Okay, okay, welcome. Okay, now I'll show you one more example. This one again is a the difference. No, sin x or x plus 5 is not in our list. Okay, if you look at the list of continuous function, they are individually there, but this total function is not there. Okay, so I have to apply the quotient rule here. Okay, x goes to 2 sin x over limit to x plus 5. Okay, so here I get sine again, something like this. I have to use the calculator. Okay, 2 plus 5, no? So sine 2 over 7. So are there any other question? Okay, so here I find the individual limits, then I plugging in because they are continuous. Okay, but this one you can do only if the denominator function is defined at that point. Otherwise, we cannot use this method. Okay, so now let's look at this example. Okay, so yeah, we need to find this limit of this function at x equals 5. Okay, so I applied the quotient rule and break it down to two polynomial functions. Now polynomial functions are continuous, so I can try to apply the quotient rule. Okay, when I apply the quotient rule, I get a 0 in the denominator. See, okay, so here I do this. This is 25, 55, 30. Now when I plug in 5, here 25. So both top numerator and the denominator, I get a 0. Okay, so here quotient rule, we cannot use the quotient rule because I get a 0 in the denominator. Okay, because if you look at the quotient rule, here it works only when denominator is not 0. See, if denominator is, this limit is 0, I cannot use the quotient rule. Numerator 0 is not problem. Okay, so for example, let's say you are finding the limit of this guy. X minus 5 over 2x plus 1. I can apply the quotient rule to x minus 5 in the denominator to 5. No, sorry, 5. Yeah, 5, 5, 2x plus 1. Here, when I plugging in the top, I get a 0 numerator. Denominator, I get 10 times 1, 10 plus 1, 11. But any number divided by some 0 divided by any number is 0 except another 0. Okay. මෙතන 0 එක බෙදන්න පුළුවන් ඕනේ නම්බර් එකකින් බිංදුව නොවන ඕන එකකින් බෙදුවතින් බිංදුවක් උත්තරේ බිංදුවයි. හරි? එතකොට නියුමරේටර් එකේ බිංදුව આવතින් ප්‍රශ්නයක් නැහැ. හැබැයි ඩිනෝමිනේටර් එකේ බිංදුව આવොත් මේ quotient rule එක වැඩ කරන්නේ නැහැ. අපිට බිංදුවෙන් බෙදන්න බෑ. හරි? So this problem we get a 0 in the denominator. Okay, this 0 in the denominator is the problem, but with the 0 in the denominator, I get a 0 also in the numerator. There is a trick we can use. හරි, මෙතන denominator numerator එකේ විතරක් බිංදුව ආව නම් ප්‍රශ්නයක් නැහැ. denominator එකේ බිංදුව ආව ප්‍රශ්නයක් තියෙනවා. හරි, ඒක එතකොට quotient rule එක දාන්න බෑ. ඒ වෙලාවට තියෙනවා ට්‍රික් එකක්. ඒ ට්‍රික් එක වැඩ කරන්නේ හැබැයි කරන්න නම් උඩත් බිංදුවක් තියෙන්න ඕන. මේ බිංදුව බෙදීම බිංදුව ෆෝම් එක. Okay, so when we try to find the limit, if it goes to 0 over 0 form, this denominator 0 is the problem, not the numerator 0. Like you see in this example, if only numerator 0, I can handle it. Okay, using this technique. What I did here, you can divide 0 by any number except a 0, you get a 0. බිංදුව ඇරෙන්න ඕනේ මගේ එකෙන් බිංදුව බෙදුවතින් 0 එනවා. බිංදුව බෙදීම බිංදුවේ undefined. හරි? එතකොට මේ මෙතඩ් එක වැඩ කරනවා උඩයි යටයි දෙකේම 0 සාවකින් තියනවා ට්‍රික් එකක්. Okay, this 0 over 0 is called the indeterminate form. Okay, but we can find a limit for that some cases. Okay, so this is explaining why that trick work. You can read that one. Okay, you don't have to I'll go over that later. I will show you the trick. Okay, so first how to solve some problems. This is the way you do. You factor out the numerator and the denominator, cancel the common guy. Then we try to evaluate the limit role for the remaining function. Okay. So for example, let's look at this one. Okay. Okay. Give me a minute. Okay. This function here, first we can try the applying the quotient rule. Okay, so this is 2 to the square minus 4 over 2 to the 2 minus 5x plus 6. Okay, so this is 10 minus 5 times 2. No, sorry. 5 times 2 minus plus 6. Okay, so this is 0 in the top and the numerator is 0. So we can try to use that method. Okay, if it goes to 0 over 0 form, so 2 I have okay. So we can try to factor this numerator and the denominator. Okay, so we can try to factor the numerator and the denominator. So factoring the numerator, this is x minus 2 plus x minus 4, no? Sorry, x minus 2 plus x plus 2 from the factoring. Okay, so we know factoring. So this is x minus 2 plus x plus 2. In the denominator, we get x minus 3, x minus 2. Okay, this is from the factoring methods. So we can factor this guy, no? X minus 2 and x minus 2 cancel out. So I am left with x plus 2 over x minus 3. Okay, so for this one, I try plugging in. මේකට plug කරලා try කරනවා. හරි? x plus 2 limit x goes to 2 x minus 3. එතකොට මෙතන ඉන්නේ 2 plus 2 over 2 minus 3. Okay, 2 plus 2, no? 2 plus 2 is 4 over minus 1, which is minus 4. Okay. මේක මේ බිඳුව බිඳුව ෆෝම් එක ආවතින් අපිට මේට එක try කරන්න පුළුවන්. අපි එකක් තමයි උඩයි යටයි factor කරන්න පුළුවන් නම් factor කරලා බලනවා. factor කරලා බැලුවම ඒක cancel වුණාම හරිනම් හරි. factor කරාම මේ උඩයි යටයි cancel කරගන්න පුළුවන් නම් ඊට පස්සේ ආයෙ මේ rule එක දාලා බලන්න පුළුවන්. එතකොට ඒක වැඩ කරනවා නම් හරි. හරි? any questions මොනවා හරි ප්‍රශ්න තියෙනවද මේක කරන්නේ අපි? එහෙම බිඳුව බෙදීම් බිඳුව වෙනවා නම් උඩ factor කරලා යටත් factor කරලා ඊට පස්සේ common factor එකක් තියෙනවා නම් cancel කරගන්න බලන්න පුළුවන්. ඒක තමයි මේ step වල තියෙන්නේ. Okay? I'll give another one. Let me. Okay, you can try this problem. Okay, මේක try කරන්න මම විනාඩි 5ක් දෙන්නම්. කළා උත්තරේ එවන්න. මම මේ logui exponential ගැන worksheet එකක් upload කරන්න. Okay, we got one answer to now. Good. Okay, let's see if you try. That's good. Maybe it's correct. Let's see. I think it's correct. Okay, okay. So first I'll try plugging in. Good. Okay. I'll wait 2 more minutes and thank you for the answers. Okay. So first let's try plugging in. Okay, so if I plugging in 1x squared plus x minus 2 using the quotient rule, no? X here, if I use the quotient rule, I get 1 plus 1 minus 2 x squared, no? 1 plus 4 minus 5. This is again 0 over 0, no? So that means I have to go for the 1. Okay, so this is we are checking here, okay, whether this limit works. It don't work if we get 0 over 0. Normally it's not good to say equal, but we are checking there, okay? Here I checked actually whether I can take that part. It doesn't work, okay? Now I try factoring. 1 අරක වැඩ කරනවාද කියලා තමයි අපි බලන්නේ. ඒක වැඩ කරේ නැහැ. එතකොට අපි ෆැක්ටරින් කරනවා මේක උඩ එක ෆැක්ටර් කරන්න පුළුවන් x minus 1 x plus 2 වලට. යට එක ෆැක්ටර් කරන්න පුළුවන් 5 x minus 1 වලට. Okay? Now this factor making them 0 cancel out, no, each other. So this is the factor that makes it 0 that I get cancel out. Okay, so I go limit x goes to 1, no, x plus 2 over x plus 5. Okay, so here I can do the limit numerator 1 5 plus 5. So here if I plug 1 plus 2 is 3, no, 3 and 1 plus 6 is 6. This cancel out. I get 1 over half, no? 1 over half. Okay, in the denominator I am left with x plus 2, no, x plus 5 and x minus 1. Then the factor that making it 0 should cancel out. See here, x minus 1, if I plug 1 it becomes 0, you know, we kind of cancel out that factor, okay, that making it 0. Then when we can use the quotient rule for the remaining function. Okay, why this method works, this is what in the handout. You can go over that, it's in your note. I'll explain it next time after you practice some of these problems, okay, why it works. Okay, any questions? මොනා හරි ප්‍රශ්න තියෙනවද? එක ඔක්කොම වගේ උත්තර හරි එක්කෙනෙක්ට මම හිතන්නේ පොඩ්ඩක් යට සිම්ප්ලිෆිකේෂන් එක මාරු වෙන්නේ නැති මම හිතන්නේ. Let's do another one. This works for other and ones. No, okay, this one. Sine squared theta minus sine squared theta plus 3 sine theta minus 4. Okay. So this one, if I try to plugging in. Any questions before this one? Okay. T, no? So here I should have set theta, no? Because I use theta. Sorry, I use theta. It should be the same letter. Okay. Here, if I plugging in, okay. So here I get sine squared pi over 2 minus 1 and sine squared pi over 2 plus 3 minus 4. Now sine pi over 2 is 1. Okay, so this gun is 1. This guy is also 1. So we get a 0 over 0 here. This is from trigonometry. Okay, I will upload a worksheet for trig and log. If you've forgotten them, you can go over that. Okay, so this is the value of sine pi over 2 is 1. Okay, from trigonometry. මේ trigonometry කරපු ඒවායි sine pi over 2 එක එකයි නේ. යටත් sine pi over 2 එක එකයි. ඒකට 3 දාන එක 4 ඍණ බිංදු 4 බිංදුවයි උඩ 1 ඍණ 1 බිංදුවයි එනවා. Okay. So this one also goes to 0 over 0 form. I have to try to factor it. Okay. So here you can think this is as a square. If you remember, we did a problem before. This is a different of a square top, no? Two. Okay, here we have this. Okay. In the numerator, limit here, this one is like a varga a squared minus b squared. මේක බිඳුව over බෙදීම එනවා. එතකොට අර factor කරන්න බලන්න පුළුවන්. මේක a squared minus a minus b plus a plus b වගේ. Okay, with the factoring worksheet. So a is sin theta, no? So top part is like sin theta minus 1 and sin theta plus 1. Okay, that is applying this a squared minus b squared different of a square formula. මේකට වර්ග දෙකක අන්තරේ සමීකරණ දැම්මම a sin theta b එකයිනේ. එතකොට a minus b a minus 1 a plus 2 නේ a plus 1 මේ a කියන්නේ sin theta. එතකොට එනවා sin theta ඍණ 1යි sin theta ධන 1යි වර්ග දෙකක අන්තරේ. Okay, different of a square gives the top factoring. For the bottom one, we'll use a trick. If you recall, you can directly do it. Okay, if you don't see it, we can use this trick we used before in that factoring problem. Here I say sin theta is x because this is the half power, no? Sin theta is x, then sin squared theta is what? X squared. So this denominator, we can write this guy plus 1. We can write this guy as what? X squared plus 3x sorry, this should be not plus 1 minus 4, no, I did a mistake here. Yeah, thank you. Okay, someone said that is minus 4. Good. Okay, I didn't show that is in the chat. Thank you. Okay, that should be minus 4. Okay, thank you. Minus 4. Okay, so this minus 4, no? Now this one you can factors of x and x, 4 and 1, no? To get the middle term, this is plus, this is minus. So x is sin theta, no? So sin theta plus 4 and sin theta minus 1. Okay, so if you can directly jump and factor this is fine. Okay, you don't have to I substitute back for x. X is sin theta, no? එකපාරින්ම මේක කරන්න පුළුවන් නම් කරන්න පුළුවන් නැත්තම් fine on. Okay, so here I get now limit theta goes to pi over 2 sin theta plus 4 sin theta minus 1. Okay, then sin theta minus 1 cancel out. I get sin limit so this is sin pi over 2 okay. Now sin pi over 2, so I capture that sin theta minus 1 goes away, no? So I get this. Now I can plugging in. So sin pi over 2 is 1 and this is 5. Okay, so I get 2 over 5. Okay, do you have any questions? මොනවා හරි questions තියනවද? Okay, මෙතන මේ ආදේශ නොකර කෙලින්ම මෙතනට substitute කරන එක පේනවා නම් factor කරන එක factor කරන්න පුළුවන්. මේක this work because this is squared and this is x, no? This is 2 times this term. It works. We learned that in factoring, if you recall. Okay, sine times this is twice, no? Power here 1. Okay, also you can use this using another method. We will learn that later when we do differentiation. Okay, L'Hopital rule, you can use this using L'Hopital rule also. Okay, okay. So there we factor, still you can factor and cancel out. Okay, also we'll learn another rule, L'Hopital rule later, but you have to be careful when you use it with trig. Okay, so ඊළඟ එක කලින් එකේ මොනවා හරි ප්‍රශ්න තියෙනවා නම් කියන්න. Okay, if you want me to explain any step here, let me know. Okay, okay, so I'll go to next one then. this one. Okay, someone got the answer for previous one. That's good. Okay. So this one again, if I apply the 3, plugging in using the quotient rule, here I get what? 3 minus 3. And the denominator I get 9 minus 3, 6, 0 over 0 again, no? So this method don't work, quotient rule method for this one. Okay, this one also you have to factor. There is a special way to do that. Okay, this is x minus 3. Minus 3. So here I have, okay. So we use a trick here because of the difference of square rule. When we have this form, what I do, here I have a x minus square root 3, no? And denominator I have x squared I multiply the opposite sign denominator, top and the bottom, okay? Numerator and denominator. The reason to do that, here if you look at numerator, this is a minus b, no? And this is a plus b. Yeah, don't mind. This part I erase this. Okay. So if I apply the difference of squares formula in reverse, this will be a squared minus b. Now a is square root x, b is square root 3. Okay, so here what we'll do in the top, you can skip this step. Okay, I'm just writing to demonstration purposes. So here this is what, limit x goes to 3. This square root x is a squared, no? This is square root x square because a is square root x. This is square root 3 squared. Okay, so you get that. Okay. Square root of x because a is x, okay, minus the denominator, you get this one. I keep it like that. Okay, sorry, this one denominator x squared minus x plus 6 minus x minus 6, and here I will keep this one. This is square root x plus 3. Okay, you have to multiply the top and bottom from the same, x plus 3. Sorry, okay, this is actually square root x plus 3 because I am multiplying by 1 here, this x. Okay, so what I do, because this is x minus 3, I multiply by x plus 3 square root. Okay, both of them square root also. Sorry, I don't know why I forgot that. So you multiply top and the bottom from the same term. Sorry, okay. So this is x plus 3 square root, this is x plus 3. But these two you can combine. These two you can combine. මේ උඩයි යටයි දෙකම එකම පදයෙන් වැඩි කරාට ගාන වෙනස් වෙන්නේ නැහැ නේ. ඒකට මේ උඩයි යටයි දෙකම එකම පදයෙන් වැඩි කරනවා. ඊට පස්සේ මේ දෙක group කරවතින් different of square වලින් මට ලියා ගන්න පුළුවන් ඒක limit x 3ට යනකොට එන x minus 3 කියලා square කරාම. okay. මෙතන මෙයා එහෙම ඉන්නවා මට ඒක වැරදුනා. okay, square root 3. Now this guy I can factor, no? X minus 1, that one I can factor x minus 3, x plus 2. Okay, now this x minus 3 cancel out. Okay, so then I have here, okay, thank you for the answers again. 1, x plus 2, but this guy, sorry, it's x plus square root x plus 3. Okay, sorry, square root 3. So this will become 1 plus 2 is 3, no? 1 over 3 times square root 1 plus square root 3. Okay, square root 1 is just 1. Okay, so 1 plus 1, 3 plus 1, 4. So 1 over, this limit is gone. Okay, when I plug in, limit sign is no more because I have already taken the limit. So it's not good to write that there. Okay, ඒක ලියන්න ඇතන limit sign එක මොකද limit එක හොයලා නිසා ඊළඟට okay, the square root 3 we don't know, no? 1 plus 3 is what? 4. Square root, sorry, 4 plus 4 plus, give me a minute, okay? 4 plus here square root of 3. Okay. 5, I actually made a mistake here. I should have write square root x and square root 3. Okay, is that where you get 5 or do you use other method? If you use other method, you can send me in the chat, okay? Here first I mistakenly write here x and 3, but it should be square root x, square root 3. එතකොට මේක කරන්නේ මෙහෙම දැම්මොත් බිඳුව ඉන්න හින්දා මෙතන x minus 3 ඊට පස්සේ මේ square root x minus 3 එක මට cancel කරගන්න ඕන. ඒකේ මෙතන plus දාලා square root x plus 3 වලින් වැඩි කරනවා. එතකොට උඩ විතරක් වැඩි කරොත් හරියන්නේ නැති හින්දා උඩයි යටයි දෙකම square root x plus 3 වලින් වැඩි කරනවා. හරි? ඊට පස්සේ උඩ දෙක group කරලා ගත්තම මේක එනවා. මේක එතකොට මට factor කරන්න පුළුවන් x minus 3යි x plus 3යි දෙකයි. ඊට පස්සේ මේ square root x plus 3 කියන එකේ එක දැම්මම square root එකයි x වල මෙතන plus එකක් නෙමෙයි තියෙන්නේ, sorry, multiple එකක් ටිකක් තියෙනවා. give me a minute, okay? So here multiple, yeah, is 5, no, sorry, 5. But here also you get a square root. This one I didn't write clearly, that's why. Okay. Here you have to, so let me write clearly. Yeah. Okay, you get, but you get additional square root term. Okay. Limit x goes to 3. Okay. So x plus 2 square root x plus 3. Now x is going to 3. I'm plugging in the 3 here. Okay. Sorry. 3 here. So this is 3 plus 2. That is 5. But there is additional part. Also. Sorry about here. Okay. Now this is 10. Sorry. Okay. 1 over 10. This one I can multiply 2 times square root 3, not 2 to square root 3. So actually I end up getting 20 times square root 3. Sorry, okay. Here I didn't write it clearly previous time. So x plus 2 is here. So 3 plus 2 I get a 5. But then I have this additional 2 over 3 part square root, okay? Because from this guy. Okay. So if you have any questions, you can ask me now. Okay, so this one I get 20 over 3 because of that additional term. Any questions? මේ පහෙන් එකයි කිව්ව එක්කෙනා ඒක ගත්ත හැටි අර මෙතන මම මේක ලිව්වේ නැති හින්දා දන්නේ. Okay, the one who asking is 1 over 5, the 5, but here again you get a, oh, I multiplied it 2 times, sorry. I multiplied it in mind, that's why. So this one still 5, no? Sorry. 5 times 2 and square root 3 is 20 times. Okay, here is correct. 20 times, not 10, 20, no? 10, not 20, 20. I multiplied it twice by 2 by mistake. Okay, that's why. Okay. Then it's fine. Okay, good. Okay. Sorry, I also made a mistake in here simplifying. So now let me go to, okay, wait. Okay, good. Okay, now I'll go to this homework problems. Give me a minute. Okay. Give me a minute to go to. Okay. Okay, so you can try this homework problem now. Let's see how. Okay, so here when you find the limits, okay, this C means you have to find the C at -1, C at +1. Okay, then here C is 2. So you have to find the limits at 1 from both sides here, limits of 2 from both sides like that. Okay, so here limit of 1 from both sides, here limit of 2 from both sides like that. Here limit of 3 from both sides here, and then check for the continuity. Okay, then a true and false. Then this part I will do maybe today or tomorrow. Now you can do this one here. This is the first type of problems I use. Okay, you can directly do quotient rule, product rule, and that like that. Okay, then here what we did today, factoring. Okay, you have to factor this equation through, evaluate limits by factoring. Okay, then I had some factor homework here. Okay, so we did worksheet, that worksheet 1 problem. Let's see, that is worksheet 3. Oh, yes, that 3. I will include a worksheet for log and exponential also. Okay, this worksheet 4, do you have any questions? I don't think you, but if you have, you can ask. Okay, now this factoring quadratic equations. If you don't got a time to look, watch it next time. Do you have any questions about this worksheet 4, or do you have any questions about the ones we did? Okay, I'll extend this due date little bit because I think it's due on Friday 12. Okay, so I will, okay, I think, okay, example 5, B and D. I'll go for that worksheet. That one, right? Okay, maybe it's a typo. Like, is this the worksheet example 5, B and D, or it has 1, 2, 3, 4? Okay, so B 5B means worksheet 4. Okay, okay, yeah, B and D. Okay, what? Okay, B and D. Oh, I see. Okay, 2 times 1. Okay, 2 times 1 is 3, both of them minus. Okay, I will show you this one by factoring. Okay, yeah. Okay, I will do in a minute. Okay, right. X squared minus 3x plus 5. I will do using the long method of factoring. It's from factoring. I'll use the long method. Okay, because if you get stuck, you can use always this method. Oh, example 5. Sorry. Okay, 5. Good. Okay, so it says 1, 2, 3, 4. So you want 3 and 4, B and D. Okay, 3 and 4, I guess. Or example 5 is labeled as, okay, 3 and 4, no? Okay, so let me copy all of it, it's easier. So 3, so I have to identify A, B, C first, okay? Okay. So A is 3, so C is 1, X equals minus B. This is the quadratic formula, no? C squared 4AC over 2A. Okay, so now X minus B. Okay, so it's two minuses here, minus 4. Okay, one from this formula, but also B is minus 4, no? So there you get two minuses. මෙතන මේ සමීකරණයෙන් එන minus එකක් තියෙනවා, B ඍණ 4නේ. ඒකක් තියෙන හින්දා minus 2ක් එනවා. Okay, then plus or minus square of minus 4 minus 4A, no? A is 3 and C is 1 over 2 times A is 3. Okay, so this minus and minus is a 4, positive 4, plus or minus. Here I get a 16, here I get a 12 over 12, no? Are you fine up to now? Okay, very good. Okay, let's see. Okay, I'm doing 3 and 4 now. Okay, so here, okay, let's see. Here I get square root of 4, no? 12. 4 square root of 4 is square root 2, no? No, sorry, 2, square root of 2. Okay, so plus 4 plus 2, 2 over 12, comma, this is, okay, I write here x equals, so here I write in here x equals 4 plus 2 over 12 or 4 minus 2 over 12. So x equals, this is 6, 12 or x equals 2 over 12. So this is half, no? Half or x equals 1 over 6. Okay, any questions? Any questions? මේක මොකක් හරි ප්‍රශ්න තියෙනවද? Then I'll go for next one. X squared plus 3x minus 4, no? X squared plus 3x minus 4. X squared plus 3x minus 4, okay, equals 0. Again, A is 1, no? B is what? 3, and x is minus 4 here, okay? So here, again, I plugging in minus b plus or minus b squared is 9, no? 9 minus 4, x is AC, no? B squared minus 4AC, A is 1, C is negative 4, okay, over 2A. A is 1, here actually I get a 1, no? Minus B is minus 3. I directly plugging in this situation, okay? So here I get minus 3 plus or minus, is it saying use quadratic formula or factoring? Quadratic formula, no? Okay. So 9, here minus and minus 16, no? Positive 16 because there are two minuses. One minus for here, which is C, minus 4, and minus sign from the formula. Okay, B squared minus, so this is again 2. So here minus 3 plus or minus 25. No, 16 here, no, sorry. So 16, 4 times 4, 25 here over 2. Okay, so negative 3, 5 over 2. Okay, so here x equals minus 3, minus 5 is a minus 8 over 2, or minus 3 plus 5 is a 2. So this is minus 4 or 1. 4 over 12 in the previous one may be possible. Let me check. Okay, yeah, 6. I don't know why I wrote 7. Thank you. Okay, because of that 12. Thank you. So this is a 6. Sorry, someone. 3 over 2 times 3, no? Okay, previous question, 6. So this is 6. Sorry, okay. This is 6. Okay, so this is 6 and 6. Here, here, and here, and here. So 6 over 6 is 1, no? 6 over 6 is 1. This will become 3 over 1 over 3. Thank you. Okay. 1 over 3. Good. Okay. Sorry. Thank you. Okay. So I think this one is okay. No, not this one. Next. This one. Okay. Welcome. Okay, so are there any person with other questions from the worksheet? Okay, so if I go for the homework, here I will extend the due date of these two. Maybe two, I will push it back 2 days more, so it collide with the two classes more. Okay. Uh, so now you can do question 1 and question 2. This one part C, I will go over that next time. Okay, one part C. Then you can also do now 4 and 3 also. Okay, one part A and B you can do. මේ එකේ A B කරන්න පුළුවන්. C එක මම ලබන සතිය කියලා දෙන්නම්. දෙවැනි ගානයි තුන්වැනි ගානයි කරන්න පුළුවන්. ඊට පස්සේ මේ ෆැක්ටරිනුත් දැන් කරන්න පුළුවන් ඕගොල්ලෝට. අපි ෆැක්ටරින් ගැන කතා කරේ හින්දා මේ කලින් ක්ලාස් එකේ කතා කරානේ ඒකට වීඩියෝස් තියෙනවා මේවට. ඕකේ. එතකොට මොනවා හරි ප්‍රශ්න තිබ්බොතින් අහන්න ඊළඟ එකේ මේක try කරන්න දැන් ඒ කොටස් එක. Okay. If you have any questions about this, you can ask me next time. Okay. Now let's see here. This explanation is explaining why that cancel out session work. Okay, you can read it. It's in the handout why this thing works. Okay, why you can cancel out and find the limit. Okay, if you are interested, you can read that part. It's in the handout. Okay. So I will stop here for now. Today I will stop little early. Okay, I had something in the morning, so I'm little tired now. Because also there are half people missing. Okay, from the last time normally there are 70 now. Okay, so මම අද ටිකක් කලින් නවත්තනවා වෙන මොනවා හරි ප්‍රශ්න තියෙනවා නම් අහන්න පුළුවන් ඉඳලා. Okay, I will wait here for 5 minutes. You can log out if you don't have any question. ප්‍රශ්න මුකුත් නැත්නම් log out කරන්න පුළුවන්. හරි මේක දැන් හරි. Okay, ප්‍රශ්න නැත්නම් log out වෙන්න මම විනාඩි 5ක් විතර ඉඳලා නවත්තනවා. Okay, welcome.
Thank you, sir.
You're welcome.
Thank you, sir.
Thank you, sir.
Welcome.
Thank you, sir.
Welcome.
Thank you, sir.
Okay, welcome. Okay, worksheet 2, example 12. Okay, welcome. Okay, I'll try worksheet 2, worksheet 4, example 2. 4. Okay, I'll try that one. Worksheet 4. Example 12, no? Okay, yeah. Oh, okay, higher degree ones. Okay, yes, okay, I'll do this one. So this one you need to use that common factoring method from the previous worksheets. Okay, so I'll do one and then see whether you need more. Then we can go to factoring x cubed plus 5x squared plus 6x. Oh no, 12, no, not 6, sorry. Oh, okay. This one. Okay, factor theorem. Okay, example 12. Okay, I will explain example 12 actually and then Example 12, multiplicity is easy, okay? So multiplicity of a root is let me copy this one. This one is not that difficult, but you might not have seen it, okay? Because it's new material, maybe you have not done it in high school. So we'll take this one. Here roots you can get by setting is to 0, okay? If I set x minus 2 to 0, I get x equals 2. This is a root, okay? And then x plus 2 to 0, I get x equals minus 2, no? Minus 2. And setting x equals negative 5 to 0, I get x equals 5, no? Then setting x plus 1 to 0, I get x equals minus 1. Now the multiplicity of each rule, okay, multiplicity of it, these are the roots. Then multiplicity, these multiplicities are given by the factor, the power of the exponent that of the factor that gave the root. Okay, so x equals 2, factor is x minus 2, no? And he is repeated 3 times here. So the multiplicity of this x equals 2 root is 3. Multiplicity of x equals minus root 2 root is what? 2. Okay, because he given by plus 2 and plus 2 I have here. And the multiplicity of x equals 5 given by x minus 5. His power is 1. So here is 1. Okay. X equals minus 1 given by x plus 1. He is repeated 4 times. So his multiplicity is 4. Okay. එතකොට මේ root එක දීපු factor එක repeat වෙච්ච ගාන තමයි multiplicity එක කියන්නේ. එතන x සමානයි 2 දුන්නොත් එයා වෙන්නේ x minus 2 වලින්. x minus 2 එක 3 පාරක් repeat වෙන හින්දා එයාගේ multiplicity එක 3යි. x equals minus 2 මෙතන දෙපාරක් repeat වෙන හින්දා එයාගේ multiplicity එක 2යි. Okay. Example 12 එක දැන් පැහැදිලිද? මේ worksheet 4 එක නේද මම ගත්තේ බලන්න. Okay, good. Okay, so any other questions? තව මොනවා හරි ප්‍රශ්න තියෙනවා නම් අහන්න මම නැත්තම් විනාඩි 5කින්. Okay, good. Okay. විනාඩි 5න් නවත්තනවා. I'll stop it in 5 minutes. If you have any questions, ask. Okay. Okay, seems no questions more. Okay, then I'll stop. Okay, I'll stop it then. Okay.
Thank you, sir.
You're welcome.
Thank you, sir.
Okay, welcome.
Thank you, sir.
Welcome.